Hello dear friends, I welcome you all for the lecture number 7 on Hammett linear free energy relationship. Before we start to this lecture, I would like to recommend two textbooks for this topic. The first the first book is a guidebook to a mechanism in organic chemistry by Peter Sykes, and second is a or a textbook by Jonathan Clayton and other. Now, the topic of this lecture is deviation from the straight line. This is very interesting and concept boosting topic. Now, in Hammett plot, we have a straight line relationship. But this straight line relationship sometimes either shows the deviation, and that deviation may be either concave upward deviation and it may be concave downward deviation. The deviation may be either concave upward deviation or it may be the concave downward deviation. So, concave upward deviation is seen when a mechanism of the reaction is changing due to the polar effect exerted by the substituent. That is, as we go from the stronger electron donating substituent to stronger electron withdrawing substituent, then the mechanism of some reaction is changing, and therefore, in such reactions, we have a concave upward deviation. For example, if this is the straight line and if the mechanism of the reaction is changing, then this straight line shows the deviation in this way. And such a deviation is said to be the concave upward deviation. Now, in some cases, we have a concave downward deviation. As now, this when this concave upward deviation is seen, and whenever there is a change in rate determining step, whenever there is a change in rate determining step, in this case, we have a concave downward deviation. This is your straight line, and there will be the deviation in this way. And this deviation is like a concave downward deviation. So I am repeating again. In some reaction shows the deviation from the straight line. This deviation may be either concave upward deviation or it may be the concave downward deviation. This concave upward deviation, uh, this concave upward deviation is seen when there is a change in mechanism of reaction, and whenever there is a concave downward deviation, it indicates that the rate determining step as we move from the electron withdrawing group to electron donating group. Then in that cases, the rate determining step of the reaction is changing. Now let's have an example one by one. Example. First example is hydrolysis of acid chloride. Now this hydrolysis of acid chloride, in this reaction, simple hydrolysis of acid chloride is taking place in acetone. And if we plot a graph of a rate constant of this reaction versus the substituent constant, then in this then we have a have expect then we have this type of straight line is expected. But this straight line is now showing the concave upward deviation. This is concave upward deviation. Or in the similar way, you can say that mm, as we move from this to this, we have a the expected we are expecting the straight line relationship. But in this reaction, there is a slight deviation. There is a slight thing. there is a deviation from this straight line, and we have a concave upward deviation as we move from the strong electron withdrawing group to strong electron donating group, or a vice versa. Now, why the mechanism of reaction is changing as we move from the strong electron withdrawing group to strong electron donating? Then, for this, we have to consider the reaction mechanism of this reaction. So, this is your acid chloride, and here we have, let me correct, this is your acid chloride, and the reaction of acid chloride with water mm, may take place by the SN1 mechanism, or by take place by the SN2 mechanism, SN2 type mechanism. In SN1 type of mechanism, this is your substituent which is substituted at meta or para position. This is formation of acetylenium cation, or we have tetrahedral intermediate, that is SN2 type of mechanism. So two types of mechanisms are possible, that is simple SN1 type mechanism and SN2 type of mechanism. Now this SN2 type of mechanism is assisted by the electron donating group as it forms a carbocation. But this same SN1 reaction, same SN1 type of mechanism is retarded by the strong electron withdrawing group. And whenever the strong electron withdrawing group is present, then it will favor this SN2 type of mechanism. And therefore here we have a concave upward deviation. We have a concave upward deviation. Let me explain in detail. This is your acid chloride, and if we have a paramethoxy group, after addition of water, polarization will take place, and this kind of mechanism can be possible. Selenium ion formation. Now the lone pair of this methoxy group will stabilizes this selenium carbocation via plus R effect, and therefore whenever this paramethoxy group or the electron donating group, strong electron donating group, like you can say the NH2, you can say the OH, you can say the methyl group. This all strong electron donating group will stabilize this selenium cation, will stabilize this selenium cation, and therefore um, will favor the SN1 mechanism. But at the same time, if we consider the para-nitro substituent, then in this case, if reaction follow SN1 type of mechanism as shown above, and if we draw the resonating structure of this, I'm writing over here. Sorry. Let me correct. Now in this case, here we have a dicatinic species, which is very much unstable, and therefore such a kind of intermediate is not possible or is not formed, and therefore whenever the para nitro substituent is present, then this reaction will not follow SN1 reaction at all, and therefore in such a reaction, and for this reaction the mechanism of reaction it changes to simple SN2 type. It shows the SN2 type mechanism. And now this SN2 type of mechanism is assisted by this nitro group, as it will withdraw the electron density of this carbonyl group. It will withdraw the electron density of this carbonyl group, and therefore making this carbon more electrophilic towards the nucleophilic attack, and therefore SN2 reaction is accelerated, and therefore this this substituent or this whenever the para-nitro substituent or strong electron withdrawing substituent is present, then we have a rho positive rho value, and for this reaction or for this SN1 mechanism we have a negative rho value, and therefore this negative rho value, that is minus 4.4, is indicating that these substituents are following SN1 type mechanism, and the rho value with plus 2.5, indicating that this reaction is following SN2 mechanism. SN2 mechanism. Now what about this para chlorine group? It is a intermediate group. And the effect of this para group is neither strongly electron withdrawing and not strong electron donating, and therefore it is following the SN1 as well as SN2 mechanism. It is following the SN1 and SN2 mechanism, and therefore the rate of reaction when para chlorine is present, then such a reaction is neither accelerated or neither retarded, and therefore the uh, rate of this hydrolysis of acid chloride when para-chlorine group is present, then in that case the rate of this reaction is very slower. But as we shift from uh, para-chloro to stronger electron withdrawing group, the rate of reaction is increases, and as this reaction favor SN2 reaction, and accelerate the rate of reaction. And as we move from this on left hand side, as we move uh, on left hand side, compared to this parachlorine group, the electron donating tendency is increases, and as the electron donating tendency is increases, then it accelerates the rate of reaction by following the SN1 mechanism, and therefore each substituent each substituent either favor SN1 reaction or SN2 reaction. So when SN1 it favor the SN1 reaction, it accelerates the rate of reaction. At the same time, those substituent which favor the SN2 mechanism, they also accelerate that particular mechanism, and therefore the rate of reaction is increases on right hand side also and left hand side also. This is the substituent with strong electron donating substituent, and this is the here the substituent present which is the strong electron withdrawing substituent. So in this way, as the mechanism of reaction changes, there is we have in that case we have a concave upward deviation. So any reaction showing the uh, deviation from the straight line, and if this deviation follow the if this deviation is concavely upward, then it clearly indicates that the mechanism of reaction is changing. In the next lecture, um, we will study the second example of concave upward deviation, that is the acetylysis of 3-aryl 2-butyl bromylate, as well as we will study the hydrolysis of ethyl ester in 99.9% H2SO4, 99.9% H2SO4. Both all these three reactions shows the concave upward deviation, which indicates that the mechanism of reaction is changing as we move from the strong electron withdrawing group to strong electron donating group. Thank you.